let's go back to our conversation here. So we have an example using destructors. The destructor will be called for any object at the end of its life cycle, guaranteed. This provides the perfect opportunity to clean up, as well as we do delete storage in our stack example, right? Then if your object does any dynamic resource allocation, like new and delete, then this is the place to deallocate those resources. And other types of resources could be open files, right? If your class, instance of your class, opens some files, open files take resources from the operating system. If you want to stay neat and everything, you should be closing your files, and Destructor is a perfect place to make sure that you close file if you happen to open the file. Right. So sometimes devices may also have some preliminary work that you need to do with them. For example, in graphics, you could have access to a certain graphic device which may ask you to allocate some things before you can use it. There, of course, you may need to deallocate that. So that's another example. Wasn't actually even hoping that we're going to get to this today. Let's observe the progress that we're making. References. Okay, since I have this little scratch pad, let's do it. Let's cover references today. Debug, stop debugging, close everything that I don't need, and simply perhaps say breakpoint delete. I don't really, once I'm done with breakpoints, I actually delete them because you don't want them hang around your projects. Control A and start with blank screen. Integer main. Okay. Integer, let's see, integer 1 equals 1. Integer 2 equals 2. All right, make it nice and neat like that. And then just making sure that I'm recording this. Okay, I do. Good. So then I want to implement a function named swap. And I want to exchange 1 and 2. I want to exchange the values. How can I do this? How can I define a function that swaps two integers? Pretty valid request, because oftentimes if I want to implement even bigger algorithm, like sorting algorithm of some sort, swapping values is pretty much all that sorting does. Like finds elements that out of order and swaps them. That's all sorting does. Takes some sort of collection of data and begins to examine, uses its own tricky algorithm implementation to find places which are out of order and swap the elements. At the end of it, everything is in perfect order. So swap is very important algorithm on its own. So void swap, right? It could be this. And so there's a function, doesn't return anything but wants to swap values. So simplistic version, int I don't know, xx and int yy, I don't know. I can do this. Int left and int right. How about this? Right, something so that I don't name all of my variables the same way. So once I call the swap, left is going to contain 1, right is going to contain 2, because these are the parameters that I pass to the function. And then I'll do this. I'll say, okay, I want to say left equals right, right? And at the same time, I want to say right equals left, right? So that's not going to work because I'm losing left right away. Exactly. So let's do temp, integer temp, some temporary, and remember what left is at this point, right? So temporarily save it, and then instead of saying right equals left, use temp in place. right? So we can do that. Okay, does it compile? It does. It does. However, it doesn't do anything useful, because if we try to say, upon return, if upon return we are going to if upon return, before we return, we set up a breakpoint, right? And we just let it go, debug, start debugging. I never built it, huh? Build, okay. All right, and start debugging. Then what happens is that this local variable, debug helps us with the local variables. Really, no swap took place. 1 is still 1 and 2 is still 2. Why is this so? Why this didn't work? Well, because by definition, when you call this, copies are manufactured, and we get copy of 1 and 2. They're happily swapped inside the function. Upon return, 1 and 2 is not affected. 1 and 2 never even knew that something is happening in attempt to swap them, right? Because copies were made. So, pointers to the rescue. Okay, so instead of passing values, let's pass addresses, and therefore we need to take address off and address off right here. By the way, debug, make sure I stop debugging, right? So now I have this. This should work. Save and build. What's wrong? Cannot convert something from. Because I'm using pointers. If I'm using pointers as is, I need to remember to dereference pointers, because otherwise it's thinking that I'm trying to assign new addresses to these pointers. So right and left now pointers. So in order to access values pointed by the pointers, I must remember to dereference those pointers. Very well, right? So now I can build. So hopefully it builds this time very well. And then you can say start debugging. We make a breakpoint, and happily 1 is 2 and 2 is 1. It worked because we said we're going to access 1 and 2 indirectly through their addresses. And that's why before calling this version of swap, now I must take addresses of these variables so that those pointers are initialized by addresses. And I know we're out of time, so that's why I think this example is to be continued next week. How about this? Because the topic is important. Debug, stop debugging. This topic is important. In essence, I will show you, just in a few seconds, that there is a possibility. So when you look at this, two things some people may disagree with is that, do I really need to use the addresses? Could I actually get away with this? Other programming languages allow me to do this, and therefore also this is somewhat confusing, and could I simplify it to its original version? And the answer is yes. Besides pointers, there are also references. And this version will also work. So now we have two versions of this. One is using pointers, another is using references. To be continued. So we just have to talk about the syntax next time. How about that? So this is exactly where we're going to resume next week.
2 weeks.
2 weeks. Thank you. Yes, 2 weeks. Next Tuesday runs on Monday schedule, so we lose 1 week. Sadly, right? Because I love this class, and hopefully you do too. And we can continue in 2 weeks. Thank you very much. I'll see you in 2 weeks. Have a great long weekend. We're all ready for it, I guess.